The epic journey of Apollo 12. In September 2002, astronomers made a surprising discovery, an asteroid caught in a very unusual orbit around the Earth. This puzzled scientists because, as far as they knew, the only natural object orbiting Earth was the Moon. This mysterious visitor couldn't be an ordinary asteroid. It had to be something man-made. As it turned out, this strange object was actually the Saturn V rocket's third stage that launched the Apollo 12 astronauts to the Moon. This rocket stage had left Earth back in 1969 and then embarked on a remarkable, almost forgotten journey, one that remained a mystery for decades before it unexpectedly returned near Earth 30 years later. So, what happened to this rocket? Why did it follow such a bizarre path? In this video, we'll explore how a tiny error during the Apollo 12 mission sent this rocket stage on a 30-year voyage through space, only to mysteriously reappear orbiting our planet. Stick around until the end, because we're also giving away an incredible Space Shuttle campus print. Find out how you can win. Saturn V rocket stages. The Saturn V rocket consisted of 3 stages. The first stage burned for about 2.5 minutes, propelling the spacecraft to an altitude of 61 kilometers. The second stage fired for approximately 6 minutes, pushing it higher and faster. Finally, the third and last stage executed a brief burn to place the spacecraft into orbit. Once in a stable orbit, the third stage would ignite again to perform the critical translunar injection burn, sending the rocket and crew on a trajectory toward the Moon. After the Apollo crew was safely en route, the third stage would separate, and NASA would attempt to discard it. On earlier Apollo missions, the plan was to send the third stage into an orbit around the Sun, where it would remain for thousands of years. To do this, NASA aimed for a lunar encounter on the Moon's trailing side, allowing its gravity to slingshot the rocket away from Earth and into a solar orbit. For NASA, such a solar orbit was ideal. The object would no longer pose any risk of interfering with future missions. But for Apollo 12, things didn't go quite as planned. What happened to Apollo 12's third stage? To dispose of Apollo 12's third stage, NASA needed to set it on a path to approach the Moon's far side. However, the initial trajectory had it heading toward the near side. To fix this, the third stage performed a final maneuver using its auxiliary propulsion system, 2 sets of thrusters that controlled yaw, pitch, and roll. Although the stage had to change its position by thousands of kilometers, the early adjustment required surprisingly little energy. Traveling at around 20,000 kilometers per hour, the third stage had to slow down by about 140 kilometers per hour to delay its arrival and meet the Moon on the opposite side. NASA executed this maneuver, but unbeknownst to them, it didn't go exactly as planned. The Saturn V rocket's guidance was controlled by an instrument unit above the third stage, equipped with its own internal guidance and 2 C-band transponders. These sent signals to Earth's ground stations for precise trajectory tracking. After entering orbit, NASA compared telemetry from the rocket and ground stations to verify its flight path. If deviations occurred, commands could be sent to correct them. However, the tracking system had a slight error, causing NASA to believe the rocket was moving faster than it truly was. In trying to correct this, NASA slowed the rocket down too much, by about 40 kilometers per hour. Enough to significantly delay the rocket's lunar approach and cause it to miss the Moon by thousands of kilometers. Instead of being flung into a solar orbit, the third stage ended up trapped in a highly elliptical orbit around Earth. For the next 15 months, Earth's and Moon's gravity continuously stretched and pulled this orbit, pushing it as far out as the Lagrange point 1. What is Lagrange point 1? Lagrange point 1, L1, is a spot between Earth and the Sun where their gravitational forces balance out. Beyond this point, the Sun's gravity dominates. Imagine a steep hill with a car trying to climb it. If the car lacks enough speed to reach the top, it rolls back down. But if it has enough velocity, it crosses over and is pulled down the other side. This is exactly what happened with the Apollo 12 third stage. It passed L1 and was dragged into a solar orbit. It finally achieved the goal of escaping Earth's gravity, but the orbit wasn't stable. Rather than orbiting the Sun outside Earth's path, it ended up on an orbit inside Earth's orbit. This meant it circled the Sun slightly faster than Earth, slowly pulling away, but eventually catching up again. The rocket returns. The third stage approached Earth again in 1986, but didn't come close enough to L1 to be captured. It continued orbiting the Sun for another 16 years until, in 2002, it reached its furthest point, Apopsis, just as Earth was nearby. For the first time in 32 years, Earth's gravity was stronger than the Sun's pull on the object. Over 2 months, Earth dragged the third stage back into a highly elliptical orbit around itself, just like before. How astronomers confirmed its identity. At this point, astronomers still didn't know what the object was. To solve the mystery, they performed spectroscopy, a technique measuring how light reflects off a surface at different wavelengths. Each material reflects light uniquely, creating a spectroscopy fingerprint. By comparing this object's fingerprint with known materials, astronomers discovered it closely matched the white titanium oxide paint used on Saturn V rockets. By tracing its trajectory backward, they confirmed it left Earth's orbit in 1971. With this evidence, they confidently identified the object as Apollo 12's long-lost third stage. Is the Saturn V third stage still in orbit? Astronomers tracked the rocket's orbit and saw it was ejected back into a solar orbit after about a year. Predictions show it will return near Earth again around the mid-2040s. This object will continue racing through space for many years, but physics guarantees it will occasionally swing back home. A special giveaway. Now for something exciting. In our next video, we're giving away this stunning Space Shuttle canvas print. To enter, simply sign up using the link below and leave a comment sharing what sparked your interest in spaceflight. We'll announce the winner in next month's video. Thanks so much for watching. See you next time.